Hello, welcome to second semester and welcome to the Day 0 Notes 6-1 Operations with Polynomials. So today we're going to be simplifying exponential expressions. To simplify an expression containing powers means to rewrite the expressions without parentheses or negative exponents. Okay, so here we have the different properties of exponents. You have learned these in Algebra 1, but we're going to be doing more complicated examples and we're just going to refresh our memories. The first one is the product of powers, and that's if you have x to the a times x to the b, the way you would combine those is to add the exponents. So an example here is 2 to the third times 2 to the fifth would equal 2 to the 3 plus 5 or 2 to the 8th. If we had variables, it'd be w to the 4th times w to the 10th equals w to the 14th. Notice when our base is a number, we don't multiply those numbers together. You only combine the exponents by adding them. Okay, the next one is quotient of powers, and that is if you have x to the a over x to the b, the way we combine them is to subtract the exponents. So it'd be x to the a minus b. Okay, so for example, if I had something like 7 to the 9th over 7 to the 5th, I would subtract those, giving me 7 to the 9 minus 5, which equals 7 to the 4th. Now 7 to the 4th would be 7 times 7, so 49 times another 49. Those numbers are too big for you to have to worry about. So if it's something like that where the number's pretty large, you don't have to worry about actually evaluating what that would equal. So now with variables, if I had c to the 14th over c to the 2nd, again, I just subtract the exponents and it would be c to the 12th. Moving right along here, we're going to do our third property, which is negative exponent property. So the definition would be if you have x, it's raised to a negative a, so some base raised to a negative exponent. What you do is you have to make that exponent positive, and the way you do that is you move the base. So I always think of it as this x here is living on the second floor because it's really over 1. It's unhappy there. That's why it's negative. So in order to become happy, it has to move. And now that it's on the first floor or in the basement, it's happy. So now, on that same notion, if we started with x on the bottom being raised to a negative power, it's unhappy downstairs. It's going to go move upstairs, and now it's happy. Its neighbors were probably not the nicest. So now that would be x to the positive a. Okay, so for example, if my base is 5 to the negative 6, unhappy where it is, it's negative. It's going to move to the bottom and become positive. Now it's happy. Variable, if I had 1 over a to the negative 4, it would move upstairs and be positive. It'd be happy now. Okay, a power of a power. Definition, if I have x and it's raised to the a and then that is raised to the b, that would equal x to the a times b. So if we have, for example, 4 squared and that's raised to the 3rd, that would equal 4 to the 6th. Or with variables, if I had p to the 9th and then that's being squared, it would equal p to the 18th. I remember when I was in school, I would get confused on tests and quizzes. I would second guess myself and I would think, is x squared times x to the 3rd? I knew it was either x to the 5th or x to the 6th, but sometimes I couldn't keep track of which one it was. So my advice to you is, if you get stuck, x squared means we have 2 x's, x cubed means there's 3 x's, so together that would be 5 x's. So then you know that you have to add the exponents. As far as power to a power, the way that you could check is, let's say we had something like x squared and it's raised to the 3rd. That means x squared is being multiplied with itself 3 times. Each of these become 2 x's, so it's x times x times x times x times x times x. Add those up to see how many you have and it'll be x to the 6th. So again, I would do that sometimes if I was, doubting myself and I wanted to be sure that I'm adding when I should be adding, I'm multiplying when I should be multiplying. So I would just off to the side on a test or quiz, I would do that and then erase it so my teacher wouldn't see it, but then I would be at least positive that I did it the correct way. Our fifth property is power of a product. So if inside the parentheses you have a product of 2 or more things, so in this case x times y, and that's raised to the a, both of those values inside the parenthesis get raised to the a power. So for example, if you have something like 2x to the third, and that's raised to the fourth power, that would equal 2 to the fourth, x to the 12th. Now 2 to the fourth, 2 times 2 is 4, times another 4. We could do that. Simple multiplication, 16x to the 12th. And I will warn you that the biggest mistake that students make is they forget to raise that coefficient to the power. They'll only raise the x, not the coefficient, so make sure that you don't do that. Raise both to the power. And if I had variables, say I had a times b to the 7th, and that's raised to the 5th, that would equal a to the 5th times b to the 35th. Okay, power of a quotient. So you would have two different quantities, two different bases being divided, so that's the quotient part, and they're raised to a power of a. Each of those also gets a power of a, so it'd be x to the a over y to the a. If you have a quotient, x over y, and that's raised to the negative a, what that ends up equaling is y to the a over x to the a. And the reason that is because you could skip a step, because if you were to give this power to both quantities, they would both be negative, meaning they would both have to move, so you could just flip it right away and make the power positive. Okay, so for example, if we have 3 over 2, and that's raised to the third, let's say, that would equal 3 to the third over 2 to the third, which is 27, because 3 times 3 is 9, times another 3 is 27, over 2 times 2 is 4, times another 2 is 8. All right, if I have variables, so say I have c over d, and that's raised to the negative 4, because it's negative, I could skip that step of writing it as c to the negative 4 over d to the negative 4, and then we'd have to move both of them. We just say it's d to the fourth over c to the fourth, because again, this would be d over c to the positive 4 power. The last property is the zero power property, and this just says that any number, any variable, if it's raised to the 0, it's equal to 1. And the reason that is think if I had x to the 5th over x to the 5th. So we all know that if you have a fraction and you have the same thing top and bottom, like 2 over 2 or 17 over 17, that always reduces to 1. So x to the 5th over x to the 5th, that's also going to reduce to be 1. But if we think about the quotient property, this would equal, where you would subtract, it would equal x to the 5th minus 5, which is x to the 0, so it's 1. So an example would be 7 to the 0 power is going to equal 1. Okay? Now, recall that a monomial is a number or a variable or an expression that is the product, so things being multiplied, of one or more variables with non-negative integer exponents. And it should actually be one or more variables and or coefficients. So something like 7x to the 5th, that's a monomial. Something like a squared b to the 4th, that's a monomial. As soon as I throw in a plus sign or a minus sign, that is no longer a monomial because it's no longer a product. There's an addition sign there. So the goal of this lesson is to simplify monomials, and there are 4 ways that you could tell that monomials are simplified, and that is when there are no powers of powers, so basically that's the no parentheses usually. Each base appears exactly once. So when you have a monomial, you're not going to have x's or y's or a's or the same number in 2 places if it's all a product. All fractions are in simplest form, so reduce them. And there are no negative exponents. Alright, so the rest of this video is going to be about simplifying expressions. So the first one here, we have 2a to the negative 3 times negative 3a squared b to the 4th times c to the negative 4th. So all 3 of these are monomials. They're being multiplied. So the first thing I notice is that we have 2 coefficients. We have a 2 and a negative 3. We're just going to multiply those 2 together like we normally would, getting a -6. We don't follow the rules of exponents for coefficients. All right, the next thing I see is I have an a to the -3rd and an a squared here. When you multiply same base in a different place, you add the exponents, so -3 plus 2 is -1. Then I have a b to the 4th and no other b's, and a c to the -4th because there are no other c's. So again, it's simplified when the 4 cases above are true. The last one here is not true. We do have negative exponents, so we have to move those down, giving us a final answer of -6 b to the 4th over a, and if it's to the 1st, I don't have to write that 1, and then c to the 4th. Now, some of you may want to move that -6 down. -6 is not a problem. That's not an exponent. Numbers can be negative. Same thing like just over here to the side. If I had -2x to the -3rd, a lot of times kids want to put both of those to the denominator, but the -2, there's not a problem with it. Numbers can be negative. Exponents can't be negative. Okay, for this next example, we have for part B 4n squared m to the 3rd over 6n to the 10th m to the -2. All right, so 4 over 6, we are going to simplify just like before. It's going to be 2 over 3. I could take a 2 out of both of them. Again, a lot of times kids want to follow the rules of exponents and say that that's 1 over 2. They want to subtract the numbers, but that's not the case here because they are coefficients, they're not exponents. Then we have an n squared over n to the 10th. Now, I told you guys to subtract those, so it's going to be 2 minus 10, and it's going to be n to the -8th, and then the m's, I have m to the 3rd over m to the -2nd. Be careful when there's a negative exponent that you're subtracting, because remember, this is going to be 3 minus -2, making that a +2, so it's m to the 5th. Alright, so again, you should notice that the n exponent is negative. We have to fix that. So it's going to go to the bottom, leaving us with a 2m to the 5th on top, 3n to the 8th on the bottom. I do want to teach you a little shortcut with this. This n to the -8th that I got in the second step, I could actually skip that step because whenever you have the same base on top and bottom, so say I have a to the 3rd, b to the 7th, c to the 6th over a squared, b to the 9th, c to the 4th, let's say. Again, if you look at each piece separately, the faster way to do this is you decide before you even simplify, where's the power of a bigger, top or bottom? Wherever it is bigger, that's where that variable will end up. So here, a is bigger on top, so it's going to be a, and then you just subtract the exponents. So it's 3 minus 2, giving me a to the 1st. Do the same thing for the b's. Where's the power of b bigger? 9 is bigger than 7, so it's bigger on the bottom, and then you subtract. So it's 9 minus 7, giving us 2. And then do the same thing for the c values. Where's the power of c bigger? It's bigger on top, so it's going to be c to the 6 minus 4, giving me 2. So back to this example, I could have right off the bat reduced the fraction, 2 over 3. Where are the n's bigger? The n's are bigger on the bottom, so it'd be n to the 8th. And then where are the m's bigger? It's on top, and again, be careful when you're subtracting a negative, because it's not 3 minus 2, it's 3 minus -2, making it a +2. So notice by doing it that way, I eliminated that middle step, and you could do that every single time. Okay, pause the video and try part C on your own. Okay, here's the answer. If you did not get that on your own, please make sure to ask your teacher tomorrow. If I'm going to guess, I think a lot of you had a 3 there because, like I said previously, biggest mistake that occurs is that students will not square that coefficient or raise it to whatever the power is. All right, let's do example 2 part A together. So this is kind of a combination of a few problems. We have in the numerator, we have -2 times 4 is -8. And then x to the 4th times x to the 5th, I add those exponents, so it's x to the 9th, y to the 3rd, y to the 6th, I add the exponents, it's y to the 9th. Denominator, there's nothing I could do at this point, so I just rewrite it. Okay, now we're ready to simplify this fraction. -8 over 16 is just a -1/2. The x's, where are the powers of x bigger, top or bottom? In this case, it's on the top, so it's going to be x to the 9 minus 3, which is 6. Where are the y's bigger? 9 is bigger than 7, so they're bigger on top. It's going to be y to the 2nd. Okay, the next problem, part B, there's a few different things you could do. You could take this negative 2 power, give it to every single thing inside the parentheses, so it'd be to the 3, to the A, to the B on top, and then to the A and to the B on the bottom. Or you could eliminate that negative right away by taking the reciprocal of the fraction, so A squared B to the 5th over 3A to the negative 2 B to the 4th, and then by doing that, by flipping that fraction, makes the exponent positive. So let's go ahead and distribute. Well, it's not really distributing, but you could kind of think of it as distributing because of the parenthesis and there's a number on the outside. So it's going to be A to the 4th, B to the 10th, over 3 squared, which is 9, A to the negative 4, B to the positive 8. Let's reduce each piece individually. This 9 has nowhere to go, so it has to just stay where it is. It has nothing to be reduced with. A to the 4th over A to the negative 4. The A's are going to end up in the numerator because 4 is bigger than negative 4, and we're going to subtract them. So it's 4 minus negative 4 is 8. And then the B's are bigger on top, so that's where my B will end up. And it's 10 minus 8 is 2. Okay, go ahead, stop the video, attempt part C on your own. Right, here's the answer. It's 1 over 64 C to the 6th, D to the 30th. Now, because nothing was left on top, you do need that 1 there. However, if everything came into the numerator, you do not have to put it over 1. Same thing here in example A. Just want to show you that I did not have to put this 1 there. Once I realized that there's other things in the numerator with it, I could have just had negative x to the 6th, y squared, all over 2. All right, that's it. Thanks for watching. Bye.